Hello everybody, welcome back to another Sudoku. Today we're going to be looking at sparsely populated diagonals by Philip. Normal Sudoku rules apply. However, along any diagonal in the grid, there must not be more than at most 3 distinct digits. Which is really something. So as you can see on this diagonal, we have 1, 2, and 3, so this must be a 2. And then this becomes a 1-3 pair, and this is a 1-2 pair. And now you can see 1, 2, 3 sort of pattern for this diagonal. Well, this diagonal has 6, 2, 9, so this is a 6, 9 pair, and this is a 2, 9 pair. This is a 2, 6 pair. And this clashes with the 2 up there, making this the 2 and this the 6. So now we've got 7, 2, and 8. So this one can only be a 2 or an 8, right? But it already has a 2 facing it. So this must be an 8. And this one is either a 2, 2, 7, 8. So it's either a 2 or 7. But now this 2 is looking at this earlier 1, 2 pair, making that that's a 1, that's a 2. Now this 2 is looking at this, making that a 9 and that a 2. And now this 2, 7 becomes a 7. You can see 7, 8, and 2 are the repeating number for that diagonal. So the whole diagonal is done now. What other diagonals should we look at? Well, this is a 4, 2, 5 diagonal, but this can't be a 2, so this must be a 5. And this is either a 2 or a 4, but it can't be a 2, so that's a 4. Does that change anything? Well, it does mean that with normal Sudoku, 4 is in one of those spots. Also, 7 is in one of these spots. 7 is in one of those spots. So what else? We've got this diagonal we haven't looked at, which is 7, 3, and 4. So this is either a 3 or 4, and this is 7 or 3, but it can't be a 7 because of the 7 down there, so that's a 3. 3, 3, 4, and then the 7 at the end. Oh, and then we've got this final diagonal I haven't looked at with 8, 1s, and 5s. So this can't be an 8 or a 5, that's a 1, which sorts out this area. Now this is either 5 or 1, and there's a 5 up there, perfect, so that's a 1. 1, 1, 1, 1. So now 1 over here is in one of these spots, 1 over here is in one of these spots, 1 over there is in one of those spots, and 1 over there is in one of those spots. This diagonal has 7, 3, and 4 in it, so a 1 couldn't fit. So this 1 possibility isn't real, which makes that a 1, that a 1, and this a 1, and this a 1. So it sort of works in a negative constraint as well. And that should be all the 1s on the grid. Okay, what do I look at now? It's another thing, it's kind of hard to see. Once you get enough in the grid. 1, 2, 3, 4, 6, 7, and 8. Can we work out any of this? Well, we do have 8s colliding in the central box, making this a 4-8 pair. And this must be a 7-5 pair, it looks like. We've got 2 5s in the grid. Now, if this were a 5, then for this diagonal, because it's so evenly spread into these empty spaces, there would need to be 5xx, and this square would also need to have 5xx, but there's a 5 in it already, which wouldn't work. So this becomes the 5. Now this diagonal has 1 and 5 in it. So could this be a 7? No, because both 4 and 8 would need to be repeated. So yeah, a 7 here would have 1, 5, and 7, and then there would be no space for a 4 or 8, because that's more than 3. So this is also a 5, and this becomes a 7. So now this has to be 1, 5, or 4, or 8. So this is either 5 or 8. Which I could notate, but I don't want the grid to become too confusing. We do have quite a few 5s left. Can I do the same logic again when I think about this 5? Because look at this diagonal, it's so perfect, just like the other one. 5xx, x just standing in for any random number, would have to be the repeated thing, there's a better word for it, along this diagonal. And there's a 5 there, so it wouldn't work. So this is a 5. Now this diagonal has 5xx. We know that these 4 cells must be 2 numbers. No more than 2 numbers anyways. We can get 5 down here somewhere. Some of the diagonals are quite small. So like, if I look at 5 on this line, I don't get much. But if I look at 5 along something like this, it becomes very, very large and full of possibilities. So this is either 5 or a 4 or an 8. I can't really narrow that one down yet. I just know it's not a 1. Threes. Yeah, if you look at 3s along this diagonal, it's already got 5, 1, and 8. So a 3 would mess it all up. There's probably a more eloquent way of saying that. There are 3 numbers, there cannot be 4. So this is either a 1, 5, or an 8. This is either a 1, 5, or an 8. It can't be a 1 or a 5, so that's 8. This is either a 1, 5, or an 8. It can't be a 1. So it's either a 5 or an 8. Now these 8s force an 8 over here somewhere. This diagonal is 3 and 1 in it. There could be an 8. No, there can't be, because this is either a 6 or a 9. A 8 would mess it up and introduce a 4th number. So this is not an 8, this is an 8. Which goes along a very convenient diagonal, because it meets that. We've got 8 and 7. Granted, that could be a 4, as long as the space could be a 4. This space can't be a 4. Wait, we've got... Yeah, we could have 7, 8, 4, I think. Is there any problem with that? No, that could be a 7. What other diagonals should be looked at now? That diagonal has 2 already, 3 and 7. 3, 7, and a 4 and 8. I'm also looking at this row, which is missing what? A 4, 6, and 7. This can't be a 7. This can't be a 4 or a 7, so that's a 6. Now this is a 4 and that's a 7. So this has 7, 3, 4, 8. We already looked at that. Oh, the 1, 2, 3 diagonal got fixed. Nice. This has 1, 5, and 4, 8. Ah, but 1 and 5 both see this spot as well as a 4. So that must be 8. 8 must be the missing link. So that's an 8 as well. And this is... can't be 1. It's either 5 or 8. Which matches with this other piece. Which is only 5 or 8, because it can only be 1, 5, or 8 in that diagonal. So this must be 4. Which aligns with this 4, 3, 7. Knocks a 4 down here. This 4, 8 pair got sorted out earlier, I didn't notice. This is 4, 7, 3 diagonal. I really like the logic in this, it's pretty neat. Four, 5, don't have the last one. Might as well look at this again since we have 4, 3, and 7 already. That means that this can't be a 5. Because 4 plus 3 plus 7 is 3 numbers. The 5 or an 8 doesn't make a difference. Well, I mean, it will eventually, but whatever. Locks 5 over here. Now this is looking at 7s and 8s. It could have a 5 be introduced. I don't see why not. Four, 5. Well, it's pretty likely that this is a 5 and not the one we don't know about yet. Ah, 5 here doesn't work. So my theory there was that this is a 4, 5 pair. And this would be the outlier. Just because it made sense to me. But a 5 here has... So you would have 5, 1, 6, 9, 3, 4. None of those numbers overlap. The 1 is guaranteed. The 3 or 4, no matter which one, isn't a 5. The 6 or 9, no matter which one, also isn't a 5. So these two unique ones wouldn't fit, making this a 5. Same for this 4, because... Oh, actually, it could work with the 3, 4. Never mind. And this could be some wild card. But this 5 works out the 5, 8 pair. Shooting an 8 up here. Now we've got 8, 6, something random. But we know from how the blanks line up that the 6 can't go here, so it must go here. And then these are mirrored, whatever they end up being. 6 here by Sudoku forces the 4 up here. Those 6s collide, putting a 6 over here. Finally sorting out this pair. It's been staring at us the whole time. Now this is a 9. This row is completed. It needs a 2. This needs a 2. This needs a 7. If I can click on it. 1, 2, 3 is missing. 4 is missing. We now know this is 3, 1, 6. This can't be 1 or 6, so that's a 3. This is a 9, it looks like. 9 over here. 1, 2, 3, 4, 5 is missing. No, not 5. 7. And 8. 9 over here. Nope. 1, 2, 3. 7. 7. 5. 6. 9. Sorry about the noise outside, there's some people walking by. 9 over there. 9, 6, and 2. And if I check, it does line up. 2 over here. 2, 9, 6. Huh, that's the same pattern. Now this is a 4. And a 3. And a 7. Finish. Alright, it would be a little bit crazy of me to check every diagonal, but I might do that. Yep, that works. That works. That works. 4, 5, 6. Oh yeah, that 1, 2, 3 we already checked out. 7, 8, and 9s. 9, 3, 1s. 8, 6, 7. Alright, then we check the other side. 7, 4s. 5, 1, 8. 2, 6, 9. 4, 3, 7. 1, 8, 5. 6, 9, 2. 3, 7, 4. 5, 1, 8. 2, 6, 9. 4, 3, 7. And 8, 5. So that's that puzzle finished. Really interesting concepts. I like the very simplistic 1, 2, 3 start, sort of building into the complexities of the puzzle. Very, very cool. Thanks for sharing, and I hope you enjoyed, and I will see you on the next video. Thanks for watching.